Today I'm going to show you how to do a brake job on the rear of this truck. Okay, these are the tools I'm going to be using today. A set of wrenches. These are metrics. Pretty much 8, 10, 11, 12, 13, 14, 15. The only one we'll be actually needing to use is the 10 millimeter today. I prefer wrenches like this. They don't work in all situations, but the nice part is I can carry an entire set from 10 to 19 in my hand, whereas the same in here would be a bundle. Vice grips just on the off chance you need it. I use this style to push the piston in the caliper back into place. A torque wrench, pry bar to help remove the caliper if you need some leverage. Hammer, new set of pads, obviously a new rotor, non-petroleum based brake lube, synthetic brake and caliper grease, and then anti-seize for anywhere that there is no rubber whatsoever, because this is a petroleum based product and that will cause the rubber to swell up. And of course, non-chlorinated brake clean. This vehicle's emergency brake actually works like the old style drum brakes on the inside. So most likely you're not going to need a tool like this. But if you're working on the one where the emergency brake is integrated into the actual caliper assembly, you will need a tool like this that has all the different teeth. Sometimes you can rent them at places like your local auto parts store, but you will need this tool so as to turn that piston back in. You will not be able to push that piston back in with something like this. So that's something you need to take into consideration before you start doing a brake job for yourself. Sometimes they do require specialty tools. So let's begin. First step is to take off all the lug nuts. Now that's an example of somebody that put this tire on without using a torque wrench. If they had used a torque wrench, this gun would have easily removed that lug nut. But somebody put it on with an air gun and, you know, ratcheted the living crap out of it. So let's go get a different way to take it off. What I've changed to is when you have a flip socket, you have an extension on it. When using an extension, you'll lose some of the power of your gun. So I changed to just a deep well 21 millimeter. Now, when doing a brake job, you'll notice that on the rotor itself, thankfully it hasn't rusted to the point where you can't see it, and they use very big letters. You have a minimum thickness of 18.5 millimeters. So what you'd do is you'd find an area that you can gain access to the entire rotor, and you'd measure using a dial caliper or a digital caliper, and you would make your contacts at 3 or 4 different points. You turn the rotor 3 or 4 different points, you turn the rotor, and what you're doing is you're figuring out if this rotor can be turned. But today we're going to be putting new rotors on, so that doesn't really apply to this brake job. So the first step in doing this is to remove your caliper and then remove your bracket. But on this brake job, the bracket itself is built into the back of the axle housing, so there's no issues with that. Now on the back of your caliper, you're going to have a bolt here, and then this truck has a new design, most likely to take out vibration, because it looks like a dampener on the bolt itself. So I'll have to get creative on how to take that off. This is the first one of those I've actually worked on. Okay, these are a 10 millimeter bolt. So once you've gotten that free, you can take that off. This actually, I just grabbed it with a pair of pliers and it came unscrewed. So once that's off, you have your 10mm here that you have to break free. Now at this point, you've got your bolts out. You want to make sure that your slides are loose, that you can actually move them. And then this one has a locking tab on it, and you pull your caliper off. If you notice here, it has an extra little tab here, but no tab here. That is to lock into here. So the next part is to pop the pads out. These front pads had a little tab on them and then a retainer. They actually fit into here. The one that goes against the piston had a holder built into it. Your next step would be to push your piston back into place. There's two ways to do that. You can take some form of clamp, scripts or whatever, squeeze it together, and that pushes it back into place. Or another school of thought, which is to expose the bleeder screw, which is right here, break that open slightly, and then squeeze the piston back in. Now this is a way to do it, but the issue with that for me personally is most of the time it's only going to send the fluid volume that's inside this chamber back into the lines. If you do it this way, you evacuate the fluid, which is a good thing because this fluid sees the most temperature changes. So it's better to actually do it, but then it might require bleeding to the system afterwards. It's kind of what level of a brake job are you doing for your customer or for yourself. Now again, like I said, you want to make sure that these move freely, and this one moves very freely. This one's a little stuck. Doesn't move as freely, and the reason is because the back of the boot is missing, and as you can see, rust is building up here. So the next step for this would be to replace this boot. Okay, and when you replace it, you want to make sure any rust inside this hole is taken care of, because that can also squeeze on this slider. And then you want to clean up your slider, or if you get a kit that comes with them, use the new ones. Okay, this is that same slider cleaned up. I just used a wire wheel on a grinder and cleaned it up very nicely, so now it should move smoothly. We have the part on order, the new boot kit for this, but it's not showing up here, and for videotaping purposes, we're going to go ahead and just reassemble it, and when those new parts come in, we'll go ahead and get them put on. Now when you reassemble it, I like to use a synthetic brake caliper grease. This is a non-petroleum based grease, and it will not cause any rubber like anti-seize will. It won't cause any rubber to swell up. So this is the type of product I use for that. Comes with a nice little applicator brush, and you can put it on all of the metal that either goes metal to metal or that needs lubrication, like slides. So now it has the same movement, and it's also protected from rust in case it were to fail. Now again, this one is actually working fine, but I do like to pre-lube these too. Lots of times when you have uneven brake pad wear, this could be one of the culprits. If these get stuck, the caliper doesn't have the ability to slide back and forth. As the brake pads are wearing down, they get stuck in one position, so they just keep pushing this pad towards the inner part of the vehicle in further and further as the piston comes out, which, if this one's locked in place, which is this pad, it won't wear very easily. So this pad will end up being a lot thicker than the inside pad, which is being constantly pushed against the rotor every time you press the brakes. So that's why you want to make sure your slides are working properly. That also applies to these slides here. If these slides freeze, you'll also get uneven pad wear. If your brakes are working properly, your pad should wear at the same rate. The next step is to make sure that our sliders are good. You want to make sure that these don't have any rust on them. That will cause them to stick by slowly moving this up and moving this in towards the center, which will locks the pads in place, and that won't allow the caliper to move. So you want to make sure that this surface is nice and cleaned off. The next step is to get your rotor off. A couple of different ways to do it. Obviously you can just grab it and see, but this one is actually frozen in place, most likely due to rust behind water getting in behind the hub assembly and the rotor itself. So you can use a product like a penetrating oil. There's all different brands out there. You can kind of hit where the holes are, where that water would have gotten in. Normally this takes quite a bit of time. So if that's the case and you don't feel like waiting for this stuff to work, what I like to do is put on the lug nuts. And the reason I do that is to protect the threads. Now you might ask, what am I protecting the threads from? This is what I'm protecting those threads from. What you want to do is give it a good smack here, here, somewhere on this surface. This is only as a last resort to hit this, because if you're trying to save these rotors and you're going to have them turned, then you do not want to hit this face with a hammer, because it will literally put dents in it that the person that's turning the rotors would have to get out. Okay, looks like it's already, just make sure, yep. Now, once you're taking your rotor off, we can see that this person does not use their emergency brake very often, or else this would be nice, clean, and shiny. Another issue that most likely that rusted slide has done is this is what happens when the pad is only making contact on one section. It barely rubs the outside section and it starts to literally shale rust like this. So basically this is the amount of pad that was touching. This part wasn't really making much of a contact pattern. So as we can see, based on the thickness of these emergency brake pads, it doesn't use it very often. Most likely because this is automatic and they throw it into park and don't really think about the emergency brake unless they're on a hill. At this point, now again, we're using new rotors. I like to clean this up with brake clean. Do not use any type of compressed air. That will blow all the fibers from the brake pads into the air and you might inhale them. Not good for your system. Now if you look and notice on the hub assembly, or actually this would be the axle housing, this little bit of rust that's in here. Now this isn't very much. It's not even causing I can't barely even feel it on my fingers. There's a little bit more here. You don't want that. And the reason why is because it actually is a height difference between the main surface and where the rust is. It's actually higher. So if you have a whole bunch over here, you put new rotors on, it's actually going to pull it away, which is going to cause the rotor to wobble in and out as you're driving. You don't want that. You want a perfectly flat surface. So you want to clean this off, use a wire brush, use whatever you need to use to get that rust off. A file works also. They actually make an air tool that has a round cleaning disc that gets right up in this area. But you want the surface between here and here to be perfectly smooth so that it fits against tightly. That way the rotor will turn true. For this next process of spraying it down with brake clean, I really highly recommend you wear safety glasses and make sure you have a catch basin. The reason why you use some type of non-chlorinated brake clean is so that you wet down that dust so you're not breathing it in. The other nice part about this is that it dries really quickly, so you don't have to worry about a residue on your pads or anything like that. Now with your new rotor, you want to make sure, sometimes they have an oily film on the rotor itself, so you want to make sure that you spray that off too. Some rotors have this film, some rotors don't. I like to do this anyway. Because it just gives you a nice clean surface for the new pads to break in on. The next step, once you have your surface nice and clean, I'll take some form of anti-seize and I'll just lightly brush it around these areas that rust up real bad. That way the next brake job will be just that much easier. You won't have to pull out the hammer to get this rotor off. Doesn't have to be a thick coat, you're just going for a nice glazing over the surface. At this point, I will also just put a little bit onto the threads. That way assembly and proper torquing at the end will be much easier and much more accurate. Okay, now that's the new rotor put into place, and just to make sure it's nice and clean, spray her off again. And again, it's amazing how quickly this stuff dries. It's only about 60 degrees out today, and it dried very quickly. At this point, our attention needs to go to the caliper. Any surface where metal touches metal is potentially going to be where a squeak is going to form, but it's not a tune you want to hear. So at that point, I'll use this synthetic brake grease and I will put it on all of the surface liberally. And you have to remember this one had the little metal teeth inside that hold the pad in place. Again, that'll be metal on metal, that movement back and forth. So you want to make sure that there's some grease up in the caliper. You also want to make sure that you put some on these two surfaces. And again, you don't need a thick coating, you just need a coating. Now some brakes will have tensioners that go into here, and again, that's metal on metal. So you want to make sure there's a little bit of coating there and there. Most of the brakes are different throughout, so you want to make sure that you're addressing these issues. Also, tidbit. Helpful hint. These hoses do not like supporting the weight of a caliper. Always set it somewhere or hook a bungee cord to it. It's nice and safe up here. You can hook a bungee cord to your holes in your frame, and that allows you to make sure that these hoses don't get stretched out of place. They can fail. They are multi-layer hoses. Now when you're getting your new pads out, you want to make sure to compare them, because again, notice this is a mirror image of it, but we want the one that looks just like it flipped over. And when you flip it over, you notice that the spring tension's on the wrong side. So we have the other side's brake pad. See, when you compare it now, the mirror image of it doesn't look the same. When you flip it over and compare it like that, it is. So now you know you have the right pad for this side. So at this point, it's time to install our pads. The first set. So once you've installed this pad, make sure that you didn't get any of the brake grease that's on these legs onto the pad itself. If you do, it's no big deal. Just take some brake clean and wash it off. Now, again, we've already got our synthetic brake grease lube put onto the metal surfaces. So then you just want to line up your tabs with the slides that go into these two sections. Okay, now they're installed. Install your upper and your lower. Again, these are 10 millimeters. Tighten them up. Okay, now that your bolts are tight here and here, I have the little harmonic dampener to reinstall. That is the completed brake job. The next and final step is to reinstall the wheel, put your lugs back on, and then make sure to torque them down to whatever the factory specs are. The reason you do this, instead of just buzzing it down with my air gun, is the same torque load should be at all 6 points. That way, as this rotor heats up and cools down through brake cycles, if it's tighter here, it's going to put more force against it, and if it's looser here, obviously less force. This will tend to pull, and this will tend to push in, which causes the rotor to turn unevenly. That's why you want to have them all torqued at the correct torque spec.